Hey everyone, and welcome to a new video. This one is part of a basics series, and we'll take a look at how to build a Docker container image and also push this one to a repository. I'm using the application or the container image that I also used in some previous videos. For example, the one about Argo rollout, also the one about Flagger, that's the application we're going to build into a container today. Yeah, the application is a Go application, and we'll just first run that, so you have an idea on what it's all about. So let's run it. Go run main Go, and we also use another file here, which is wsgo. We need to run this. Let's do so. Yeah, that opens up a port 8080, that is. And the application will also connect to Redis. We do a ping to Redis and we get a pong back. So here I know that our Redis connection is running properly. This application then results in this user interface. So it exposes a static website. I'm going to like this, yes, because I changed the color. It exposes a static website on the root. But this application, this static web page, which is a Vue app, is using the socket.io client libraries to establish a WebSocket connection or a real-time HTTP connection to the server component that I just started. So it both offers the static web page and it offers the socket.io server component from the same Go executable. To illustrate to you that it is indeed listening to a Redis channel, we can use the Redis CLI, which is now connected to localhost on my system, to publish a message, hello, to a channel which is called device01 in this case. And the client is just hard-coded to pick up this message from the server. The color scheme is really working well. You see that I have great design skills. Okay, that's the application. That works. That's fine. Let's just look at how the application was built, but in a very basic manner. Right? This is nothing. It's not a Go tutorial or something. But what you can see here is we have a simple main.go. We use a Redis package and a Go socket.io package from someone called Google Lee. The application requires a environment variable called Redis host. If it's not set, the application will connect to localhost 6379. Once the connection to Redis is made, it subscribes to all the channels using a pattern subscribe. Didn't have to do that, but I just did it this way to make it quick and easy. A little bit further, we do that ping to Redis, and that's why I got the pong back as well, which is here, so I can see that my connection is working. If there's no Redis host to be found, that will result in an error, and we just print that error there. Then we establish our WebSocket server. We save it, a reference to it in the server variable. And then, and that's the main part of the application, we consume messages from Redis. We do that here. We use a channel, a Go channel for that. And that was actually created earlier. So here the channel was actually created. And here we range over that channel, so to speak. So we just wait for new messages to arrive on a channel in Redis, and then we broadcast this message to the connected socket.io clients easily with this broadcast to method there. And of course, in the end, we need to map our WebSocket server or our socket.io server. We need to map this to where the client library by default expects it, the defaults we're using, so /socket.io. And then when we go to the root of our web server, we use the handle function, and the handle function is defined here, and we simply do a serve file Could have done that differently, but I chose to have the, let's say, a handle function to, let's say, also build in things like some error logic or something. If I want to create a container that returns errors to, let's say, do a test with canary releases when errors are returned, that's easy to do within this handle function. Yeah. Now the logic for the WebSocket server is actually here in this file. So what we do there is we specify when there's a connection from a client to the server, log this out. You see this here, new connection from, that's when a browser, a socket.io client connects to the server. Then we have a new one. And then when my client application says, I'd like to join channel, this case, device 01, that's handled by this function here. So when there's a message coming in, a join message, so to speak, from a client, then we actually join that connection to that channel. So here you see it, join channel, and that's basically how it works. So we see here that we say yes, this client, the browser that connected, so the browser client that connected, which is this one, that one now joins channel device 01. So whenever now a message on a channel in Redis, which is the device 01 channel, when a message arrives within that channel, the client picks it up and just displays it on the screen. That's basically what the application is doing. Now, I'm going to disconnect from that application. And you have seen how to run this locally. Yeah? That's just running the Go application locally. There's nothing special about that. That's how it works when you're doing your local development. But now you have the task. Let's make this into a container. And that's why we need to create a container image. Now, to create a container image, of course, you have to have Docker installed on your PC. That's done already. You want to do that yourself, just go to docker.com. You'll find the instructions. They are very clear. And to create a Docker image, we need a Docker file. I have a Docker file here. That Docker file is a multi-stage Docker file to build a Go app. Why multi-stage? Well, in this case, because I want it to be the smallest image size possible. You'll see in a moment that the image will only be around 10 megabytes for the entire socket.io server and client to be served from that executable. And to do so, we will use a build container as a first step. Here you see this, the build container. And then we'll actually have and you'll see that here we have a finale container in Italian then maybe. And that one takes the build files from the build phase and puts it into a smaller container image. So let's see how that works. Within a Dockerfile, you can set arguments and you can then reuse them later. That's with the arg command. So argument go version 1.11. We then use that variable here to start our first or to build our first image. And we're actually saying we need the Golang tools. We need the tools from Go to build the application. And that's a Golang image on Docker Hub. For each version, it's available. So we use the Golang :1.11-alpine, so small as possible image. We call it build. And now we run some commands in there. And for example, we need Git. Okay, we can run the package manager APK from Alpine to install Git. And we can set a working directory. We just say /src. If it doesn't exist, it's created within that intermediary container that we are using now, the build container. Then we copy these files here, go mod and go sum. We copy that into that source directory. That's for Go modules. That's fine. You don't have to know what that exactly is. Basically, that's all the modules like the Google Leap package, the Redis package. We have to download them because we need them when we compile our application. Then we download them, and the actual step here is to run go mod download to actually get all the application packages that we need. Then we import our own code, but yeah, I made it easy there. I just said copy all the files. So we copy all the files to that let's say the working directory, yeah, the src folder. And then we run our our tests in code. There's a very small test here to test if the socket.io server is working. So we do go test to run our, let's say, unit tests here. We also then, and that's important, after the test is successful, so we don't error out of that test, then we do a go build. So go build in this case, Go now runs on Linux, so it knows it has to, this is a Linux image, what we're running in, so it knows it has to build a Linux application, and we create a statically linked binary with this command over here. That means that the intermediary build container that we are using now has in the source folder, it has this, it has all the source code, and it has built from that source code an application which is here in the root. It's called app. So that the executable is called app within the root. And we say, okay, that's good. We have that result. Everything worked fine. Now we go to stage 2. And in stage 2, we actually build a second container. So we build a new container. But in this case, we build a container based upon Scratch. That's a special container, which is actually size 0. It's an empty container. We call that finale. And then we just copy in that empty container, we only copy our app. So we copy /app from build to /app in that Scratch container. But of course, that's not enough, because our application expects within the root now in this case, because the app is in the root, it expects the assets folder in the root as well. And the assets folder contains the index.html file. The index.html file contains our client-side application, which is a Vue.js application, which is using socket.io client to connect to our socket.io server. So we need to have these two steps here because these are the files we need. Then when this container is run, right? When this container, this very small container built on Scratch is run by, let's say, Kubernetes or another system, we have to start the /app application, the Go application we just built, we have to start it. So to actually build the image, we are going to use Docker build. And remember, the result of Docker build will be the last phase, by default here, the last phase in our multi-phase or multi-step build. So that means this will be the container built by these steps. That will be the container that's finally built by the command I'm going to use now. So I'm going to say Docker build. And we are going to tag the image. Now, the image should be specifically tagged if you're going to upload it to a registry, which is a location. Yeah, it's either a private one or in the cloud, a public one, where you can store your images. The registry that I'm using is Docker Hub. So Docker Hub is a publicly available registry. I have an account on that Docker Hub registry, which is called gbake. And I can store my images over here. Now, in order to do so, I need to specifically tag the image that I'm going to build. Yeah, so I'm tagging it with the name of the, let's say, registry in my case, so gbake. I don't have to specify that I'm going to Docker Hub, because when I'm doing this, the Docker command knows we're going to the public Docker Hub environment. So I'm calling it gbake, and I'm calling it WS test and version 1.0.0. So yeah, this is the, let's say the name of the container is actually WS test. This is what we call the tag of the container. This is just the repository within, sorry, this is actually a link to the registry we are going to use, which is the Docker Hub registry, and my account within that registry. Now, I also have to specify the file I want to use, the Docker file, but you can do that with -f if I'm not mistaken. But if you omit that and you just refer to the current folder where you want to run your Docker build, it will take by default a file called Dockerfile, which is in the folder we are right now, right? So let's do that. We do the build, and this is this multi-stage one. So the first container which is built is the build container here, and you can see that Go mod download is now busy doing its work. What you see there, all in red. That's a result from this step here, the go mod download command, which is running within this build container. Yeah, that's usually, you're using Node or you're using Go or something else, it's always the slowest step. So you got all the packages downloaded right now. He's doing some copy commands. Now the actual Go build is run to build our statically linked application and put it in /app. Then of course creating the Scratch container is very fast because that's just 0 size image. We only have to copy the application and the assets and it's done. So that last step is really, really, really quick, right? This means that, yeah, with the command we have run, that there should be an image on my system, on my local system, which is called gbake/wstest and that tag. Let's check it out and see if we can find that. So Docker images is a command to list images. I have many, I could have filtered them, but I'm just going to go through the list. It should normally be the first one you see there. And indeed, we have gbake/wstest with the tag 1.00. The size is fairly small, as you can see here, which is 10.4 megabytes. Great. Now, before we upload this one to Docker Hub, let's try it out first. So let's run this container. And let me first copy the this one here. So gbake wstest. Let's clear this out. Not clear, just clear. Let's do a Docker run. Docker run, we first of all want to expose the port on our local host. Yeah. So I know that this application is actually using port 8080. So I want to expose port 8080 in the Docker container to port 8080 on my local machine here. What I also need to do, and that's very important, I want to set an environment variable. The environment variable, if you recall, the Redis host environment variable needs to be set as well. But I have Redis running on my local machine. It's not available within the image I'm running. I need to specify where my Redis host is. That's not localhost. That is indeed my local machine. Let's run ipconfig. Let's see what my IP address is. That's this one, right? And let's tell him to use this IP. And I can never remember the port of the Redis server. 6379. Yep, that's the one. Let's also add that, right? And then we specify the name of our container. Again, just to clarify, Docker images. And let's see what it is. And indeed, gbake wstest. But we'll also need to add the tag there. Now, what I also want to do is I want to run this interactively. So I'm going to also use the -it command as well. We run this. This should now run the container we built a moment ago. It runs it on my local system. It sets the environment variable. It's exposing the port as well. It's running interactively, so you should also see the ping and hopefully also the pong reply from the Redis server. And that doesn't work. Why doesn't it work? Because I'm not using the correct syntax or setting an environment variable. That's the one. So good that you see an error. You'll probably have this yourself or could have this yourself as well. So it's easy to see how to repair it. The server component is now running in a Docker container, but exposed on port 8080 on my local host. Let's see if that really works. So let's go to my client, localhost 8080. Does it still resolve? Yes, it resolves. But does it connect to my Redis machine? Let's find out. Publish this. And indeed, he's still listening to my Redis server. And he shows the message in the user interface. Great, that's a good thing. So now we only have one thing left to do. And what is that one thing? We have to push this to our registry, because I'd like to use this from anywhere in the world. So I need to put my image somewhere. So for example, I can use a Kubernetes system or something else, something like Azure Container Instances or AWS EKS, whatever. We have to push it somewhere. That's in this case with Docker push. And of course, that means you need an account on Docker Hub. So create an account there, and you have to also make sure that you use the Docker login command first to log in to that repository. If you don't do that, naturally you won't be able to push an image. I already did that, so I can just do Docker push, and I'm going to use the same name, of course, of the container image on my system. When I do so, that should go relatively fast, right? So there we have it. It's pushing it, but it's not ready yet. We'll wait until it's ready here when the actual result is showing up. Yeah, there we have it. And that means now if we refresh Docker Hub, we will see that there's a new image available, which is the WS test image. Logically, if, for example, my system now wouldn't have that image available and I want to run it, I can just run the same command here. If this image, WS test, wouldn't be available, it would be pulled from the system. Let's actually try and do that with Docker RMI. That's removing an image. We're going to remove actually the whole, I'll just copy it here. I think it's -- force, right? It's now removed, which means if I now run the command as before, and I refer to the image here, it's not on my local system. It will need to pull it. It will not do that automatically, and since it's a very small image, it's done very rapidly. That's essentially what Kubernetes is also doing. If you submit the manifest to run this application for the first time, Kubernetes needs to download that image from the repository, from the registry as well. Let's see if that is done. Yeah, unable to find the image locally. It pulls it, it starts it. We have our POM, and we can see here that the application is running again, right? So that's it. You have seen how to build an application that was written in Go. We have built it with a multi-stage Dockerfile to keep the resulting image as small as possible. After building it and testing it on the local machine, we pushed the container image to Docker Hub, which is a registry. And then we also showed you when you have removed the image from your local system and you try to run that and you have a reference to the container which is correctly referencing a remote registry, it will pull it from that registry as well. That's it. Thanks for watching. Till next time.